Dear students, in this video we are going to see the experiment number 8, implementation of clustering algorithm using self-organizing feature map for the course 20 CS 2032L Machine Learning Techniques Lab. So to start with, SOFM is a type of artificial neural network which is mainly used to do the clustering operation. So clustering means nothing but grouping of similar items together. And it is coming under the category of unsupervised learning approach, which is trained based on the competitive learning algorithm. And the SOM is developed by the Professor Kohanen in the year 1980. The other application of SOFM are dimensionality reduction, and also it is used for detecting the features. That's why the other name for it is self-organizing feature map. And the SOM basically reflect the artificial neural network, and it has the two layers. One is as an input layer and one act as an output layer. And the SOFM, the output layer nodes will be organized in a two-dimensional map. So to know the understanding purpose, we have organized this two-dimensional map in a one-dimensional linear way. And these are our input features, that is input nodes which is available in the input layer, and the output node having the clustering labels. Depends on the number of clusters, we have the output nodes in the output layer which will be organized as a two-dimensional map in the SOFM architecture. And for each input connected to the output, that is assigned with the weight. So during training process, these weights get updated using the competitive learning algorithm. So whenever we give the input, and we have the output node here, and this output node we need to have inputs from x1, x2, x3. So the output node will receive inputs from x1, x2 and x3. So the corresponding weights will be assigned as W11, W12 and W13. So the distance between this input and the weight will be calculated based on the Euclidean distance. So the next step, we are calculating the distance between the input features and the weight connected with the particular node using the Euclidean distance. And based on the distance similarity, whoever having the similar, that is very closest distance value, and that will be selected as a winning node in the output, or we can call as best matching unit. Once the best matching unit is identified, basically the nodes will be organized in a two-dimensional map, and for the winning neuron or the winning node, the neighbors around the winning node will be considered. So the weight of the winning node along with the neighbors around the winning node get updated. And this is the formula for updating the weight. The new weight will be calculated based on old weight into learning rate. Alpha will be considered as a learning rate, and then the distance between the input and the weight value. And here there are two parameters which will be updated during the training process. One is the learning rate and another one is the radius. The radius represents the number of neighbors around the winning neuron. The neighbors around the winning neuron will be considered in a circular format, or it will be taken as a linear format, or it will be considered as a rectangular grid, or it can be considered as a hexagonal grid. So the radius of the neighbors will be getting reduced, or exponentially it get decayed every time when the number of iteration increase. At the same time, the learning rate also we are trying to reduce at every iteration. So this is the formula for the radius for decaying the values in every iteration, and this is the formula for decaying the learning rate. And SOFM mainly run in 3 stages until it reaches the convergence. The first is the competition. What is it competition? So whenever we give the input, suppose we have 4 features and we have the cluster labels. Either it can be C1, C2, C3. The data are the instance we are having here. Suppose we have 100 instance and these instance will be grouped into 3 different clusters C1, C2 and C3. So the input layer having this input features X1 to Xn, the output node having C1, C2, C3. And we take the first instance, we pass the first instance through the input layer. And each node connected with the output layer or the output node having the equivalent weights. So W11, W12, W13. So in the beginning step, we calculate the distance between this input feature and the weight value, and the node which will be having the less distance, that will be considered as a winning node. So we are doing the competition around the nodes so that the node which containing the less distance will be winning in the competition. And the next is the cooperation. That is, after finding the best matching unit, we need to find the neighbors around the neighborhood. So it is cooperation because the weight value of the winning neuron get updated along with the neighbors around it. And the next thing is adaptation. So based on the distance and the winning neuron and its neighbors, the weights get adapted by using the competitive learning algorithm. And this is the algorithm steps. First, we have to import the necessary libraries required to implement this algorithm and load the given input data set which contain the features x2 up to xn. And if there is any missing value in the particular column, and that column alone, we have to do the imputation by using the mean imputation. And the next step is we need to normalize the values. And next is we need to initialize the parameters needed for the learning algorithm. The learning rate and how many number of clusters we need to have it to divide our data, and then the neighborhood radius for the best matching unit. Generally, the neighborhood radius will be taken as half of the number of the clusters we consider, and how many number of iteration we want to execute the algorithm. Before executing the algorithm, we will visualize the input features distribution using the scatter plot. So now the training starts. We need to perform the algorithm by running the same algorithm for the different maximum clusters. That is, the data can be either divided into cluster 2 or 3 cluster or 4 cluster, 5 cluster, because depends on the problem, selection of the number of clusters will be varying. So we are executing the algorithm for each clusters, that is cluster 2, cluster 3, cluster 4, cluster 5, and finally we find which is the optimal cluster for the particular problem. To select the optimal cluster, we are calculating the Silhouette score. So we will execute the algorithm with 2 clusters and calculate the Silhouette score. We execute the algorithm with 3 clusters and calculate the Silhouette score. So the cluster which is giving an optimal cluster value and that having a maximum Silhouette value, that will be considered as a best or optimal number of clusters for that particular data set. So to do that, first we have to initialize the weight. Next, you take every instance of our input and calculate the Euclidean distance between the instance and the weight. And out of the output nodes, we need to find out which have a minimum distance, and that will be considered as a winning neuron or the best matching unit. And now we need to update the winning neuron's weight and its neighborhood. So after every iteration, we need to decrease the learning rate and the neighborhood radius based on the iteration number. And we have to decide the optimal number of clusters by using the Silhouette score, which have a maximum value. Next, we have to plot the curve against the number of clusters and the Silhouette score. So from that, we can able to identify the number of clusters which having the highest Silhouette score, that will be considered as a optimal number of cluster. So once the optimal number of clusters is finalized, we need to assign the cluster labels and visualize the clusters with different colors in the scatter plot. Now we will see the Python implementation to do the step-by-step procedure for the SOFM clustering. First, we need to initialize the parameters such as number of iteration, learning rate and the maximum cluster. So we are going to iterate the SOFM algorithm with the different clusters as 2, 3, 4 and 5. So by using the for loop ranging from 2 to 5, we are going to compute the SOFM clustering, which needs the information as the input data, number of iteration, learning rate, neighborhood and the number of cluster. Initially it will be 2. The neighborhood will be decided as the number of clusters divided by 2. So this function will return cluster assignment, cluster centroid and the cluster labels. So based on the cluster assignment, we will compute the Silhouette score. And this will be repeated for the clusters 2, 3, 4 and 5. And out of these 4 clusters which having the highest Silhouette score, that will be considered as a optimal number of clusters. And to work with SOM clustering, we have defined the function with the step-by-step procedure. Initially, the weights will be initialized to the random number. So this weights represent the connection between the input node and the output node. We start the iteration. In every iteration, we take one data point at a time and then compute the distance between the input and the weight using the Euclidean distance. And the node, that is the output node, which having the minimum distance, that will be considered as a winning node or the best matching unit. So once the best matching unit is identified in the output layer, the neighbors around the BMU also identified, and then the weights of the BMU and the neighborhoods get updated. So the weights get updated depends on the neighborhood. Along with the neighborhood and the BMU, the weight get updated using the competitive learning algorithm. At the end of every iteration, the learning rate and the neighborhood size get decreased. And this get repeated for the number of iteration. And every iteration, we need to calculate the cluster center. So once the weights get updated, based on the weights, we have did the cluster assignment. And for that particular cluster assignment, we calculate the cluster centroid and the corresponding cluster labels at the end of every iteration. And at the end of the SOFM algorithm function, so every cluster, what will be the cluster assignment, cluster centroid, cluster label, we will get as a output. So from the Silhouette score, we will identify which will be the best optimal number of cluster. The Silhouette score with maximum value will be considered as the optimal number. So why we have added 2 here? Since the Silhouette score is an array which consider the values from 0, 1, 2 and 3. Because if you run with 2, 3, 4, 5, the 5 will not be considered. So it is running only 2, 3, 4. So this 0 index will be equivalent to the number of clusters 2. So that's why it will return the index value we have added. This is correspond to the number of clusters 2. And based on that, we are trying to plot it. The plotting will be given with the X label is the number of clusters and the Y label is the Silhouette score. and the score which have a maximum value, that will be considered as a optimal cluster, that you can view it by using the plot. And once it is done, for the particular optimal cluster what we selected, we execute the SOFM clustering algorithm once again, and finally we identify what is our final cluster assignment, cluster centroid and the cluster label, and that we are trying to display the cluster centroid and the cluster labels. Once it is done, we need to plot the scatter plot to get the distribution of our input data with different clusters with different colors. Suppose the optimal number of clusters 3, then we have represent 3 different colors, red, green and blue. So we consider 2 features from our input data set. By using scatter plot, we have plotted the values of our x1 and x2 distribution. So now the optimal number of clusters 3 means, and this will be given in one color, and this will be given in one color, and this will be given in one color. So based on the optimal number of clusters, the datas, the colors will be given in different thing, and the cluster centroid will be marked with some symbols. So the cluster centroid get differentiated from the cluster value. So you can see here the cluster centroids will be given with the marker star symbol. The other values will be given in either red color for the first cluster, green color for the second cluster and blue color for the third cluster, and the centroids will be marked with the marker symbol with the black color. So you can view after the algorithm executed how the data get grouped or clustered into different colors based on the selected optimal number of clusters. I hope you are clear to have a theoretical knowledge about how the SOFM is working and also how to implement the SOFM algorithm to do the clustering in a step-by-step procedure by using Python. Thank you.